Hello, welcome back to the workshop. I live in an area that used to be rural, that the city has grown up around. But because it used to be rural, I don't have access to municipal water or sewer. Instead, I have to get those things myself. I use a well for drinking water, and I use a septic system for sewer. Because the city has grown up around us, we are now within 5 miles of an airport, a landfill, and an abandoned coal mine. And because of that, the water that comes out of the ground, it's not great, it's pretty polluted. So in today's video, I want to show you how I take that polluted well water, how I filter it, clean it, and turn it into drinking water. Specifically, using a reverse osmosis system. If that interests you, stay tuned, we'll get started. Before I show you how I clean the water, I want to show you what's in it. These are the results from a test I did that started me down this path. Bear with me here, this is going to get a little boring, but I promise it's important. The first two on the list are copper and zinc. These likely leached out of our plumbing due to corrosivity of the water. The next on the list, nitrates. Those are caused by things like agricultural runoff and sewage. The recommended maximum is 10 parts per million. At 9.1, the lab was concerned enough, they called us and said, don't drink the water. There are 1900 parts per million total dissolved solids in our water. These are minerals and metals like calcium and sodium. Recommended levels for this is 50 to 150 parts per million. Ours is so high that crystals grow out of the pipes and fixtures. Sulfates typically come from mining and similar industrial processes. The recommended maximum for sulfates in water is 500 parts per million. At 930, we're nearly twice that. Corrosivity is a measure of how aggressive the water is. Ours came back at minus 0.7. Our water is incredibly corrosive. That's why we see so much copper in the sample. It is literally dissolving the pipes from the inside out. And last, selenium. High levels of selenium usually come from things like mining and fracking. The recommended level for selenium in drinking water is 50 parts per billion. We found 65. My main concern are the nitrates, sulfates, selenium, and the high total dissolved solids. So with that in mind, and after a lot of research, I've decided the best way to clean this is reverse osmosis. Here's a quick overview of how that works. We'll take a look at each of these in detail in a moment. Raw water is drawn from the well. It is softened to bring down the TDS somewhat to help prevent fouling of the RO membranes. It is then passed through filters to remove contaminants before passing through the RO system. The clean water is stored in a storage tank. Water is then pumped through a neutralizer to reduce acidity and put some minerals back in the water. It's filtered again to remove excess neutralizer and then passed through a sterilizer to kill bacteria and pathogens. It is now clean and ready to drink. This is our well. This one is 320 feet deep. The water level starts at 80 feet. That means you have to go down 80 feet before you hit groundwater here. This one has a submersible pump at the bottom. That pump pumps the water up and into the house. This is a 60-gallon pressure tank. Water is pumped from the well into this tank. What this does is it provides constant pressure to the house. This one operates between 40 and 60 psi. So once water is pumped into here, it supplies a constant water pressure between 40 and 60 psi. The water in this tank is still untreated, raw well water. The raw water then flows through a series of pipes from the pressure tank to a water softener. Most, if not all, reverse osmosis manufacturers say that their system won't work above 2,000 parts per million on TDS. Since ours is so close to that, the water softener reduces the hardness a bit. This reduces the potential for fouling the RO membranes and improves efficiency of the system. The softened water is then piped along the same route to the inlet of the reverse osmosis unit. There are two pre-filters on this RO unit. One is a 10 micron sediment filter and the other a 5 micron carbon block. These filters protect the RO membrane from sediment, but more importantly from chlorine. This is the reverse osmosis unit. This one is made by Axion. It is their Flexion AT1000 unit. This one is rated at 1,000 gallons per day. That is, under ideal conditions, it can produce 1,000 gallons of water per day. It has 3 RO membranes and uses a pump to push water through those membranes at 120 psi. RO performance is contingent on two things, TDS and temperature. Higher TDS and colder water both reduce the output of the RO system. Those ideal conditions I mentioned earlier, those are 50 parts per million TDS and 77 degrees. Our water is 1900 parts per million and 58 degrees. At those conditions, the 1000 gallon per minute system, it really only makes 700 gallons. The RO system, though, is quite effective. It reduces the TDS from 1900 to around 18. I'm using a 160 gallon tank to store the fresh water. Our house uses about 500 gallons per day, and this tank is about the right size. The RO unit uses a simple on-off float switch for control. I found this causes the system to short cycle. To remedy this, I added a second float switch and made a control box using an Arduino to turn the system on or off based on float positions. I don't want the tank to overflow and flood my basement, so I added a level alarm to the tank that will sound if the tank gets full. It also cuts all power to the RO. Now that we have clean water, we have to get it back into the house plumbing. A booster pump draws water from the tank and pumps it into a 30-gallon pressure tank. This pressure tank operates between 35 and 55 psi. The clean water is then fed through a series of pipes to a neutralizer. Water tends to become slightly acidic during the RO process, and this neutralizer uses calcium carbonate to neutralize that. The water then passes through a final filter to remove excess neutralizer. From there, the last step, water is passed through a UV sterilizer. This sterilizer uses UV radiation to kill any remaining bacteria that may be in the water. This one is rated at 15 gallons per minute, and it's about the right size for our use. I would like to talk about the cost of this system. It can be prohibitively expensive. The RO unit you see right here, just by itself, was more than $10,000. When you include the pressure tanks, the booster pump, the neutralizer, sterilizer, and the plumbing, all of this adds up to more than $20,000. So if you're putting one of these systems in, keep that in mind. It is going to be expensive. We've been using this system now for more than 2 years. I built it back in January of 2020, and really the only things I've had to do are maintenance related. I replace the UV bulbs once a year. I weekly flush the RO membranes, and about every 6 months I change the filters. It has not been an expensive system to run. Now, I mentioned that the upfront cost of installing this thing was just absolutely insane, and that is the case, but once it's in, it's been a really easy system to live with. So when we bought this house, we had water we couldn't drink. We didn't have a usable water source. Adding this system, we now have water that is near bottled water quality. I mean, you can't beat that. It was expensive, but given that we had no alternative, this system has worked out really well. If you're subscribed to my channel, I want to say thank you. I just passed the 1,000 subscriber mark, which blew my mind. I never thought I could get something like that. So thank you guys for helping make that happen. If you're not subscribed and you enjoyed this content, would you consider subscribing? I put out videos about once a week. They're typically on a topic like this, something in the workshop or some other thing I'm working on. I want to thank you guys for taking the time to watch this. I know this one was technical and it was kind of boring. If you found yourself in the boat I found myself in though, I think the information here is valuable. I wish I had somebody who could show me the stuff that was involved when I started down this path. There was a lot of learning, a lot of information I had to come up to speed on, and the marketing around these RO systems is a lot of bullshit. It's a lot of hype. So trying to get through the marketing numbers and figure out what you actually need, that was tough for me. So hopefully putting that into a video that you guys can use will be helpful. So with that, let's call this a wrap. Thank you for watching.